tessellations are tilings that have no gaps, no overlaps, and can contain any number of geometric pieces. However, we usually add a few more rules to make things interesting. So rule number 1, the tessellation must tile the floor that goes on forever with no overlaps, no gaps. Rule number 2, the tiles must be regular polygons, and they must all be the same. So a regular polygon all has as a polygon that all the sides are congruent and all the angles are congruent. And rule number 3 is that each vertex must look the same. So every vertex has the same types of shapes and same numbers of shapes going around it. Tessellations that follow these 3 rules are called regular tessellations. So, which of these regular polygons can be used to form a regular tessellation? Well, let's go through it. So, a regular triangle or equilateral triangle, a regular quadrilateral or square, the regular pentagon, regular hexagon, regular heptagon, regular octagon, perhaps other ones as well. Well, think about it. Let's start with triangles. Do regular triangles tessellate? And the answer is yes. Notice what happens at each vertex. The interior angle of each equilateral triangle is 60 degrees. So if you take up every vertex has 6 triangles going around it. So 60 plus 60 plus 60 plus 60 plus 60 plus 60, that adds up to 360 degrees, which is one loop around a circle. Squares, yes, they can tessellate. And in fact, every angle of a square is 90 degrees. And notice that if you go around a vertex, there's 4 squares. 90 plus 90 plus 90 plus 90 is 360. So again, these things add up to 360 degrees. Pentagon, looks like there's going to be a gap there. If I use 3 pentagons, there's a little bit of a gap. The interior angle of a pentagon is 108 degrees, and if you go 108 plus 108 plus 108, that's 324 degrees. That's a little bit, that leaves a little bit left. You're not going completely around a circle. So if I use 3 pentagons, that's a little bit of a gap. If I use 4, I'm going to end up with an overlap. So you can see that a regular pentagon does not tessellate. Hexagons? And yes, they do. And in fact, if you go around a hexagon, every interior angle is 120 degrees, and 120 plus 120 plus 120 is 360 degrees. And in fact, this is the third and last regular polygon that can form a regular tessellation. If I go heptagons, you can always do 2 side by side, but anytime you do a third one, it's going to be an overlap. Same thing with any higher number of sides. So, any other n-gons? And the answer is no. All polygons with more than 6 sides will overlap when you get to that third shape. So there are only 3 regular tessellations: the equilateral triangles, the squares, and regular hexagons. Alright, so there are hundreds of different tessellations that can be made using combinations of regular polygons. So you can combine triangles and squares, or triangles and hexagons, or squares and hexagons. So I'll leave it to you to try to design several tessellations that can be used as floor tilings. But here are a couple of examples. The one on the left is a combination of regular hexagons and equilateral triangles. And then the one on the right is regular octagons and squares. One of the more famous people to use tessellations is the Dutch artist M.C. Escher. He is known for his mathematically inspired woodcuts, lithographs, mezzotints, which often incorporate tessellations like the one shown. In fact, you can make your own, and I'll leave that to you as your own project. But one way you can do this is take a square, cut out irregular shapes on two sides, and paste them to the other side. Like you see, like this side right here was moved over to the opposite side. This part here was cut out and was taped to the other side. And so that gives you a shape, and in fact it will tessellate. And you can draw little pictures and have little faces like you see in the example.